Okay, I want to apologize and for the delay in getting this video posted. And I appreciate your textbook. This document has been up, but I wanted to kind of just spend a little bit of time kind of explaining a little bit more. And so the final exam for our class is scheduled for Tuesday, June 8th. Um, I am making a change from the syllabus. I know the syllabus originally said 9 a.m., but I'm gonna go. We'll go with 11:30 to 1. This is kind of the time scheduled with the registrar, 11:30 to 1, and then we'll also have another exam from 6 to 7:30. Hopefully, one of these times will work for everyone kind of around the world. And if for whatever reason it doesn't, let me know right away, and we can try to make some kind of alternative arrangements. It's going to work a lot like kind of the midterm exams and things that we've already seen in this class, and that you'll log in, you'll have your webcams on, you'll be muted. I'm not going to be recording or anything. And again, it's mostly there to kind of just make sure you're working on your own and you're not having some kind of final exam party with a bunch of friends or something like that, and collaborating there. Just like all of the other exams, the exam is open note, open book. Um, and if I overall this quarter, I'm still, and I apologize, and I'm still grading your midterm, but the midterm one scores came back fairly high. The midterm two scores seem to be on higher than averages from years ago and things like that. And I think that's one of the consequences of having exams that are open note and open book. But that's fine. And I'm happy for you guys as students that that despite us being online and having kind of this, it's not great for a lot of you, at least in this class, with regards to this class. It's not going to be hurting your GPA, and hopefully you can relax a little bit more as you study, and that you don't have to worry about having to memorize everything and things like that. So that's a minor, I guess, perk or whatnot. I don't know if it balances out all of the everything else that kind of wasn't fun about distance learning, but there we have it. So that's going to be our final exam. It's mostly going to be, the exam is going to be pen and paper. The exam is going to be pen and paper. And I'll post that, and you'll write your answers on pen and paper. But some of the calculations you're going to need R to do it with, okay? And basically, you'll use R as a calculator for some of these calculations, and then you're going to just kind of copy your answers over onto the paper, okay? Unless you want to figure out some way to kind of knit the output of R along with your scans into a single PDF document, which I guess is allowed, okay? Because when you upload stuff onto Gradescope, basically you just upload one PDF, and so I figured the kind of the easiest thing would be just to kind of copy and transcribe some of the answers over from R onto your paper. But if you, for whatever reason, feel compelled to scan in your document and kind of knit it together with our output so it stays as one file, that's up to you. I don't want you wasting your time or getting stressed out during the exam figuring out how to do that. So I was just saying, just take a pen, write the numbers over, and that's fine. Okay. All right. So okay, let's talk about the final exam topics. And to be honest, I'm hoping the exam will cover at least the steps. So you'll spend some time kind of learning and familiarizing yourself with some of the topics covered in the class. But again, some of these questions, as I'm describing these, I'm laughing because I don't think they're going to be crazy hard. I mean, I hesitate to also say that just in case somebody makes a mistake. I don't want anybody to feel bad for making a mistake. We all make mistakes too. So anyway, for SVM, what I'm going to do is I'm going to provide basically some pictures of SVM results. You'll see some dots, colored in, kind of different colors. And then you'll see a boundary line between kind of your two groups of dots, okay? And basically, depending on where that boundary line is, I want you to decide, was this a linear kernel or was this a radial basis kernel? And if it's a radial basis kernel, did this have a very high cost or low cost, or did this have a high gamma or low gamma? And so kind of, I think one of the lectures, was it week 6 or 7? I think at the end of week 6, no, week 7. I apologize here. Yeah, so if you look at the week 7 lecture and you kind of go through, there's a bunch of examples of different gamma values and different kind of cost values, and hopefully you can get a sense of how those boundaries get drawn. Okay, and again, kind of the analogy I use is if you have a low gamma, it's kind of like having a cable that's a little bit harder to bend, and you can get tighter corners with a low gamma if you have a very high cost. Okay, on the other hand, if you have a high gamma, it's like having a very flexible cable that can kind of create tight bends and kind of a little bit more of a squiggled output, even with a low cost. Okay, let's keep going on. We'll look at the Canon classifier. And with the Canon classifier, I'm going to show you a picture. And there's going to be a small data set there with basically the current assignments. And it'll say this belongs to cluster A and this belongs to cluster B and things like that, or not cluster. I'm sorry. Yeah, K-means clustering, and so this will be a small data set. I'm sorry, my eyes are playing tricks on me. Okay, I started talking about KNN and then I started reading K-means clustering. Okay, the KNN classifier, I'm going to provide a picture, and the picture will have points labeled in 2 classes. I apologize. Points labeled in 2 classes, and then I'm going to draw a test point, and I'm going to say what should this test point be classified as, right? And so I'll say, if K was 1, is this going to be, in the in class A or class B? If K was 3, and basically, it shouldn't be that hard. You can it'll be on a grid, and you can count out the distances from one point to another. Or, if you have a ruler, you can just take a ruler and you can kind of just measure out and say like, okay, which points are the closest or something, right? I mean, if you even have a compass, you can even draw a circle. I don't know who still has a compass, right? That feels like something you used in 7th grade and maybe haven't touched since. But yeah, you can use a ruler or a compass, and you can kind of figure out which ones there are. There's no actual calculations that you need to perform there. You can either count out grid lines, or you can use a ruler or something. So that should be fairly straightforward as far as identifying which K points are the closest or the nearest neighbors there. Okay, now let's talk about K-means clustering. Okay, with K-means clustering, I'll provide a small data set, a handful of data points, okay? And that small data set will have assignments. And this will say, this is currently in cluster 1 or cluster 2. And then I'm going to ask you to kind of perform one kind of complete iteration of K-means clustering, right? So based on the current assignments, you'll have to calculate the centroids. And once you calculate the centroids, you'll reassign all of the points to the nearest centroid, right? And so there's a little bit of calculation there. Hopefully with this small data set, it's not going to be too tedious to calculate the centroid. You'll have to find the X and Y coordinate of centroid 1 and the X and Y coordinate of centroid 2. And then you'll have several points to reassign based on the location of centroid 1 and centroid 2. Okay. The EM algorithm, we're going to do EM algorithm for kind of a mixture of multivariate normal points. And so as far as using, so to calculate the kind of the density value, I think you'll definitely want to use R. I mean, it's possible to do it manually, but oh my goodness, it's a pain. So you'll just use MVT norm. So make sure you're familiar with how to use MVT norm, right? So so the function is DMV norm, and you can kind of review your homework, but definitely make sure you can also just manually use that function to calculate the density, DMV norm, for some two-dimensional point given a value of sigma, value of the mean and sigma matrices, right? So I'll provide kind of the current estimate of the mean of, say, cluster 1 and the sigma matrix of cluster 1, okay? And then using that, you'll have to calculate kind of DMV norm for the full data set, okay? And then once you do that, then you'll have to calculate the membership weights of these points given their values, okay? So, there's 4 or 5 points, and you'll have to, based on these, the membership weights, you'll calculate the membership weights. And then once you have that, you'll calculate the new mean and sigma matrix, all right? Sigma matrices of cluster 1 and cluster 2, right? So that's going to be kind of one full iteration. You'll have current estimates of the mean and sigma matrix, and then you'll use R to calculate the new weights. And then, and using the new weights, you'll recalculate the new means of cluster 1 and cluster 2 and the new sigma matrix of cluster 1 and cluster 2, okay? You can probably take a look at your homework, and you can probably set up, chunks of your code from the homework so that you can kind of enter in the data points and work through this quickly. I would say you can start off with some kind of code in place so that these calculations can be streamlined. Okay. All right, and then lastly, you'll have, well, not lastly, second to last, kind of the last calculation-based thing will be principal components analysis. You'll need R there, and I'll give you a small data set, maybe 6 points or 5 points in 2 dimensions, and you will find you'll center the data, find the covariance matrix, and then you'll use kind of eigen to figure out what your first principal components direction is. Then you'll project the data X onto the first principal component direction, and you'll kind of report back what the values are after you project the data into that first principal component. Basically, you have to do something very similar to this in homework 6. So I would say make sure you do homework 6. And I think that will give you some good kind of practice or training as far as this task goes. Okay. And then as always, I'll probably throw in, I will throw in a handful of conceptual questions, kind of covering all of these topics and whatnot. And you'll answer those as well. Okay, I hope that clarifies any kind of questions you have, and that's it. I'll see you guys on Friday, kind of for our last lecture together, and I guess for the academic year, and for some of you forever, since you're graduating. So, so that will be it. All right, see you guys on Friday.